debate of the major candidates, while the second group did not view the debate. After the debate had aired, both groups were asked to report their intention to vote. The question was formatted on a Likert scale, 5-point Likert scale. 1, I do not intend to vote in the next presidential election. 2, 5, absolutely, I intend to vote. Then they asked the question, did the exposure to the presidential debate relate to whether undergraduates intend to vote in the next presidential election? So we have our null and alternative hypotheses. And our null and alternative hypotheses is basically telling us that these groups are going to equal 0, right? And alternatively, you can write group 1 is equal to group 2. So the estimated population mean of 1 is equal to the estimated population mean of group 2. And in this case, you would have 1 equaling those that viewed the presidential debate, and 2 equaling those that did not view the presidential debate. So pardon my bad handwriting, so viewed debate is equal to 1 in this case. And you could just insert that in here. And then 2 is did not view the debate. And then you could write this in words too and say that there will not be a significant difference between the means for intention to vote for those who watched the debate, though compared to those who did not watch the debate. That is, they will be equally likely to vote in the next presidential election. And that's how you would explain that. And you do this for part 2, or the alternative hypothesis, where in this case it's going to be not equal to 0. And alternatively, you could say mu1 does not equal mu2. And also, we know that in this case, there's no direction. So we know that this is going to be a two-tailed test. So in this case, now we're going to be going into filling out the critical value. And so let me go ahead and move this to the side here. And we're going to go to our t-critical table. And here's our t-critical table right here. It's the same as before, just slightly different, I believe. And so in this case, what we have here is, I'm going to have to move this over to this side. This has got too many things open right now, so I just have to move things around. Okay. So we have this bell curve right here, and we're going to need to find the t-critical values for this. And what we do know from based on our data is my data is showing that we have N1, which is going to be 21, and N2, which is going to be 21. Again, this is my data, and my data is going to be different than your data. So you're going to need to go into your SPSS and find what your data represents. So with this, I would do 21 plus 21 minus 2. And that will give us degrees of freedom equal to 40. So now what we need to do is we need to go back into this table. And we're going to go back into this table, and what we're going to be doing is we're going down here when it comes to degrees of freedom. And I'm just going to draw this out because I'm a visual person. So the first thing we're going to do is go down to degrees of freedom until we reach 40. And in this case, 40 is right here. So now we need to figure out, do we have a one-tailed test or a two-tailed test? In this case, we don't know the direction. It says whether graduate students intend to vote. So we don't know the direction of the outcome. And so, or the dependent variable, whether it's going to be group 1, that's going to be better than group 2, or group 2 better than group 1. So we have a two-tailed test. And so in this case, we're using two-tailed. And since we do not have p-value, we assume the standard protocol is to assume that since it did not give p-value, then its p is less than 0.05. So we're going to move down to two-tailed right here and find where it's 0.05, and that's this right here. And then we're going to move down until we get to 40, which is right here. Do I have that aligned right? I'm just going to draw it out. Yep, that's 2.201. So I'm going to write down, here's my mean. Here is 2.021. And that is going to be the T critical. And I also have negative 2.021. And that's going to be the T critical on the left side. And so this is going to be divided, the 0.05 is divided here, which is 0.025. That's the p-value here, and then 0.025 here. That's just extra information. But what you need to know is write down these two T criticals right here. But just know that the p-value is divided by 2. All right. So next thing is conduct a two-tailed independent sample t-test using SPSS, and then calculate the Cohenstein. This is going to be the hand calculation that you'll do for this assignment. Other calculations such as the T statistic you will not need to do because SPSS is going to do it for you. So since this is an SPSS focused class, we're not going to get boggled down by the hand calculations. We're going to sort of be a little bit more reserved. So you're going to go into analyze here, and then go into compare means. From compare means, you're going to go into the independent samples t-test. And now I'm just going to right click this so to display names. What I have here is this is going to be my grouping variable, the independent variable. We'll have two groups. Did watch the debate and did not watch the debate. Or actually, did not watch the debate is 0 and did watch the debate is 1. So we need to define these groups. So as you see here, I'm going to move this over. Did not watch the debate is group number 1. And if I toggle this, that would be 0. And did watch the debate is going to be group number 1, and this is group 0. Group 1, group 0, and group 1. So in this case, I'm going to go and put that for 0 and 1 because we're comparing those two groups. And then vote intent, that's going to be our dependent variable. And then we're going to estimate the effect size. But we're also need to hand calculate the effect size too. So I'm going to click OK. And what we see here is this represents little n, So just imagine that this is a little n, and this is group 1 is 21, group 2 is 21 as well. That's how many participants are in each group. And as we see here, there's no missing values, so that didn't show up. But just so you know, this is N1 is this right here, and this is N2. And then we have the mean for it, for N1, which is 2.43, and the mean for N2, which is 4.19. And I think what I'll do is I'll go ahead and use this Epic Pen, because then I can kind of organize this a little bit better. All right. Here's what we have. This is going to be N1, and this is going to be N2. And as we see here, the mean for N2 is going to be 4.19, and the mean for N1 is going to be 2.43. Standard deviations and the standard error. Really, you're going to need just some of this information here. And what we also have here is we have the F statistic, which we're not going to use until we get to the ANOVA, but just know that that's there. And we have this other information here, which is we have the p-value. In this case, the p-value is 0.01 or 0.014. That represents p-value. The sig, so we would say p equals 0.014. And then we have our t statistic. And then we've already did this, calculated degrees of freedom. And then we have a, oh, you know what I did wrong here? This is our Levene's test. So this is showing us the homogeneity of variance. So danger, danger, danger. Let me write this in red right here. This is our p-value for our assumption homogeneity of variance. Its reading is fundamental. I should have read the description right here. Assumption of homogeneity of variance. Right here. That's this. This right here, I'm going to write this in green. This is our p-value for our calculation. This is not our p-value for our calculation. This is our p-value, which we see right here. P is less than 0.001. So we would just write p is less than 0.001. So we have that information here. And we also have our confidence intervals right here. So this conveniently did this all for us. So we could put that information in if we need to, if it's asking for that. And I think what we might be doing is getting confidence intervals for the Cohen's d. I'd have to read the question first. But in this case, you will get confidence interval for the effect size. And here is our effect size. So let me go ahead and write this down right here. Let's go ahead and move this up so that we can kind of see everything again. Yeah. Okay. That's how it was. Okay, so, all right. This is our effect size. Doesn't matter if it's negative or positive, it's our effect